Now let's talk about a very important notion in object-oriented languages, and that's the notion of immutable types. Before we get to immutable types, let's refresh our memory about accessor methods and mutator methods. In a previous video, we talked about two different kinds of methods, accessor methods and mutator methods. We said that the get methods in the rectangle class were accessor methods because they provided access to the fields. And we said that the set size and translate methods were mutator methods because they actually modified the fields. Well, we need to clarify this because it turns out that different people use the term accessor differently. You might see someone talk about accessor methods as both getters and setters because getters provide read access to some part of the object and setters provide write access to some part of the object. This is a traditional meaning of accessor for people who are talking about certain languages or certain types of components. For example, you may hear the term accessor used in this way when people talk about JavaBeans. JavaBeans are a specific type of Java component that encapsulates many objects and follows strict conventions for use, like providing getters and setters for those objects. However, we're not going to use the term accessor in this way. Instead, we'll use the term accessor method in contrast to mutator method. In this usage, an accessor method is one that returns some information about an object, but does not modify the object. In contrast, a mutator method is any method that does modify the object. In this usage, a getter method is a kind of accessor method, but an accessor method does not have to be a getter method. Likewise, a setter method is a kind of mutator method, but a mutator does not have to be a setter. This distinction between accessor methods and mutator methods is an important one. Recall that in a previous video we distinguished between primitive types and reference types. With primitive types, a variable holds a value that directly denotes the type, like 47 for an int, 3.14 for a double, or false for a boolean. Reference types are different. A variable of a reference type holds a reference to an object. A reference is simply the memory address of an object on the heap. But when it comes to reference types, there's another distinction that's important to understand. Reference types can either be mutable or immutable. A mutable reference type means that object values of that type can be modified. For example, an array object can be modified. The array has a fixed number of cells, but the values in those cells can be changed through an assignment statement. In contrast, an immutable reference type is one whose object values cannot be modified. That is, they can't be modified once they have been created. The object values will stay the same for as long as that object exists. For example, the string type is immutable. Once a string object has been created, the string will not change its value. Note that strings do have, for example, a concatenation operation, a plus sign. However, if str1 is hello and str2 is world, then the expression str1 plus str2 returns a brand new string, hello world. It does not modify the existing strings hello or world. Let's look at an example. I think most Java programmers, even novices, would understand that if str1 is hello and str2 is world, and then you concatenated the strings and assigned the result to str1, you would end up with str1 being hello world and str2 still being world. But string is a reference type, so string variables have both a reference value on the stack and an object value on the heap. Let's look at these two variables, str1 and str2, from that perspective. The variables reside on the stack, and they hold references to string objects on the heap. In this case, str1 refers to a hello string, and str2 refers to a world string. So the question is, if these two variables and these two objects represent that pre-state or the before state, what does the post state or the after state look like? I'll give you 5 seconds to pause the video and think about this. Really try to figure out the answer before you start the video again. 5 seconds starting from now. Okay, here's what the post state looks like. The key thing to understand here is that a new string is created by the concatenation operation. The string object hello that resides at memory location at 41 is not changed. Again, it cannot change because strings are immutable. By the way, the word mutable means changeable, and the word immutable means not changeable. Notice also that the reference value of str1 has changed. It now references the new hello world object at address at 61. Remember, I just made up these addresses. The real memory addresses are hidden from the programmers. Notice that the concatenation operator is what creates the new string object. The assignment operator is what changes the reference value of the str1 variable. There's no way for the Java compiler to guarantee that a type is immutable. If you want to create a type that is immutable, you have to be disciplined about your approach. One way to do it is to make sure that your class has no mutator methods in it. If your class does not contain methods that modify the object state, meaning the fields of the object, then your class is immutable. Take a look at the string methods in the Java API. The methods all return values, and none of them modify the value of the string. In other words, the string class does not have any mutator methods. It's a great example of an immutable type. When you're designing immutable classes, a good practice is to declare all of your fields final. When you declare a field as final, it means that you cannot reassign values to those fields. It prevents you from inadvertently changing the values of those fields through assignment. Now, you're still allowed to initialize these variables, but once you do, they can't be used on the left-hand side of an assignment statement. Notice that if you declare a field with a primitive type as final, then it's a constant. This is because primitive types can only change their value through assignment, and final fields cannot be assigned to. If you declare a field with an immutable type as final, it also means that that variable is effectively a constant. Variables or fields with reference types have two values, a reference value and an object value. If the field is declared as final, that means its reference value can't change. So it's always pointing to the same object. And if the field has an immutable type, that means that the object it points to can't change either. Therefore, a final field with an immutable type always points to the same unchanging object. However, if you declare a field with a mutable type as final, it does not mean that that field is a constant. True, you cannot reassign to it because the field is final, but since the field is mutable, you can modify the object it points to. When you're declaring a constant, you're typically going to declare it to be static. A field that is static belongs to the class rather than a particular object. An example would be the declaration of a constant pi in a math class. You only need one constant pi, so there's no need to duplicate the same constant across multiple objects. But static fields are not just useful for constants. Static fields are useful anytime you want to store information in a single field at the class level. For example, if I had a chicken class and I wanted to keep track of the number of chicken objects that I had created since my application started, I could create a static field named chicken counter that was incremented in my chicken constructor. Every time I create a new chicken object, the field gets 1 added to it. Here's a little example to get you used to static variables. A cash register class has 4 constants, quarter value, dime value, nickel value, and penny value, that are declared static to the class. When individual cash register objects like CR1, CR2, and CR3 are created, those objects have all the non-static fields and non-static methods that are declared in the class. But the cash register class itself holds the static constants. Typically, fields and methods are accessed by prefixing them with the object name, but these static constants are accessed by prefixing them with the class name. We say that a static field belongs to the class. A regular field, a non-static field or instance variable, belongs to an object. And a local variable, including parameters, belong to a method. Since we've also talked a little about memory in the last video, it may be helpful to know where each of these kinds of variables reside in program memory. Recall that there are typically 4 areas of memory in a program. 1, a read-only code area that holds the program instructions for the JVM. 2, a global area that holds variables that last the life of the program. 3, a stack that holds information associated with method calls. And 4, a heap that holds objects. A static field lasts the life of the program, so it's stored in the global area. A regular field belongs to an object, so it's stored with the object on the heap. And a local variable or a parameter belongs to a method, so it's stored on the stack. In the next video, we will trace through some code to cement your understanding of the concepts immutable and mutable types that we talked about in this video.